Should we start? Okay. All right, so today we're going to talk about JavaScript and about how we can improve the JavaScript output from Haxe. To put some background, a couple of years ago I noticed a video that went quite viral from Dan Abramov from Facebook. So they were showing live editing of a React application. And by live editing, that means it has his editor on one side and the browser on the other side, and he could edit the view code, save, and the application would refresh without reloading the page. That is, imagine you're down like a checkout flow and you're editing the last form and you don't want to redo it 100 times to get your UI right. So that was kind of illuminating. Key technologies here, React on one side and Webpack. We're not just going to talk about that, and what we're solving for Haxe is not specific to getting React and Webpack and doing exactly that, but long story made short, to somehow achieve that, we need to split the Haxe output, at least somehow. So we have a plan. I'm going to start with a few information about the JavaScript module system, because it's needed to understand how we're going to split things. We're going to go with code splitting, technically how we approach it and how we achieve it. I'll go with Webpack. So you don't have to use Webpack, but I'm going to tell you a bit about it. And finally, this technique that allows to reload code has been coined as hot module replacement. I think there's been the name is from Webpack because that's how they call their subsystem doing that. And why module? Because that is JavaScript modules that we're hot reloading. So let's go. So I've done a lot of Flash since ActionScript 1, 2, 3, and I did a whole lot of code splitting my Swift at the time, and I think the problem is a bit similar here, how you break down your application in modules. And before that I was doing a lot of JavaScript, and after that I've been doing a lot of JavaScript and Haxe JavaScript in particular, because that's been my main job for the last 4 or 5 years. So a lot of you, I think, will not be familiar with all that is happening on the JavaScript side, except, oh gosh, I heard about this JavaScript fatigue. Seems to be the worst thing ever, and yeah, certainly a lot of things are happening. It goes very, very quick, and you can't humanly keep everything in your head and follow everything. And you got to understand that the people in this ecosystem are on a forced march to reinvent the language, to reinvent tooling, practices, everything. And of course it goes with a lot of dead ends and misdirections, and sometimes it sticks and sometimes it changes. And this is all ported by Hype. So when you have a million developers, you cannot just say, hey, look at that, that's cool. You have to bring the Hype machine and communication and marketing and thought leaders and everything. So there's nothing inherently wrong with that, because otherwise nothing would happen. But what that means is that Haxe is not a Hype machine, and it gets really under the radar. But yeah, let's try to catch up on some cool stuff. Some background again. So 2010, Node.js, about this time, Node.js and Npm, Node.js. So we had JavaScript on the command line, and that really drove a revolution in the JavaScript world, and also NPM with the NPM repository, which means you can download your libraries. And that was the change, because before you would just go on jquery.com, get your script. Like when doing Flash, we would go to this Starling website to download a zip with a Swig and stuff. Yeah, that was really a pivotal change. Then the task runners came very strongly with Grunt, Gulp, and this kind of tooling. And it all came together with the fact that people started to automate a lot more, and you had to use a bundler, a JavaScript bundler, to use these JavaScript modules that was introduced by Node.js. With the task runners, also the concept of watchers came. So the fact that something monitors your file system and recompiles, rebuilds and refresh in your browser. And for the story, yes, so ES6 TypeScript kind of appeared at this time, yet very few people used it. The real transition was around 2015 when Babel and Webpack became mainstream. And that's the new age of JavaScript. And we kind of dwarfed by what's happening here, and there are cool things happening, so we want to be able to use it. So JavaScript modules. So JavaScript modules, the main system being used is CommonJS. So it was introduced by Node.js as the way to encapsulate the relationship between a script and another. So the principle is that you make a script, and instead of being something that is global, like normal JavaScript, you don't have to fiddle with creating an anonymous scope, and you just write your code and say, and export what you want to make public. So the basic way is to attach to the default exports object, or you can completely replace the exports object with any arbitrary JavaScript value. So you could say module.exports equals 2 or hello or a string. Any value is valid. And to use that as a consumer, you're required. So that's the famous require, which is the CommonJS module system. It is not the require.js script, which is completely different. So you require another file, and what you receive in exchange is the exports. So the file will be evaluated just once to create this exports object, and then every time you require it, you get the same object. And so that's all native to Node.js, and it's all well and good. It encapsulates the script. Everything is private, except what you export. That's really nice, and that doesn't work in the browser. So to make that work in the browser, you need to transform it. And I should have talked first about Npm Libraries. So when you have your local files, and when you want to bundle that, package that, and publish that to NPM, you have to make a library. For the library, the code doesn't change, but you will add a JSON file that documents your module with a name and an entry point, which is the main JavaScript file. You npm publish it, and then you can install it from the cloud. And instead of requiring with a relative path, you require with the name of the module, and that's the same. That was, that was just so simple, and that's quite brilliant in its design. And ES6 is basically just syntax sugar on that for the import system. Basically now is the most common module system. So that, as I said, that doesn't work in the browser. So to make that work in the browser, you need to transform it. And the granddaddy of that is Browserify since about 2011. And what it does is that it will create the anonymous scope for every file and provide the module object, the exports object, and make everything work. And that is relatively efficient. I mean, there's a tiny bit of overhead, but overall that's pretty good. And what Browserify does is that you tell this is my entry point, and it will go through all the requires one by one. Require that and that and that and that and that. It goes and recurs in your project and gets all the script in a single JavaScript file, Haxe style. The CommonJS API is perfect for that. It's really obvious. All the dependencies are explicit. Before you would have things global, so you would have to link your jQuery file in the browser, and you would have a global jQuery variables or dollar variable, and God forbid if you didn't add your JavaScript, as everybody does once in a while. So that's all explicit. Haxe, say, it's been a bit boring lately in a way that it was pretty good from the beginning. You had a single JavaScript, nice and all, with all you needed. Progressively, we had some more dead code elimination, source maps, and all of that. And JavaScript toolings are just scratching the surface of doing dead code elimination. And I mean, it's been here, so it's not really exciting. It's all done. You don't realize that you need it until you need it, and then, but that is not really, that doesn't make that much hype. So we're in this case where JavaScript is all split into small files, but we have just one single one. So as I said, the key to get everything elaborated to work in JavaScript is you have to split this single bundle. So in the JavaScript world, they kind of have cracked it now. So since the task runners, as I said, we went from a collection of JavaScript files to a big bundle, and now a big nice round JavaScript is good until it's not. So you you minify, you compress, you optimize your code, but you still end up sometimes with some fairly large amount of JavaScript. And there's this one very important metric these days. It's called time to interactive, and it's the time between the moment you load your page and the moment the user can do something. And this has been proved to be, even a minor improvement has been proved to be better for business. And then you have something which is a valid return on investment, something that people will worry about and try to do better. And there's only so much you can achieve by compressing and minifying and gzipping. At some point, when there's too much code, there's too much code. So you have to remove some of the code. And if you don't want to remove features, you have to make them on demand. So you can imagine if that would be easy to extract features on demand, you can probably imagine what you could remove and load only when necessary. So if you're a game, you probably have an intro, the main game, and then you would have a module for registration, a module for multiplayer with a lobby and a chat, a module for, I don't know, a world editor. Normal process with Haxe is that you have a gigantic JavaScript file, while a lot of those features are unneeded for a user. And in terms, and the business is really about how you how you acquire new users, and for that you need to give them the best streamlined approach, where the less code is loaded, so they immediately are in, and then you add features, you add things that you want progressively. So how do we do that with modern tooling? So the main idea is that CommonJS, if you think about it, it is a synchronous API. So CommonJS is all synchronous by default. And likewise, in Haxe, all imports are in principle synchronous in the way that there's nothing that tells a tool that this code is not needed now and I'm going to need it at this moment. So for that we need to introduce an explicit asynchronous API, and in JavaScript they have that. It's so it all resembles that, which is the future API for ES6, which is import a certain module, and when it's done, then I can do some work and it's available. The principle being that tool will see that and say, all right, this file can be taken in a separate bundle, and this file and all its dependencies can be taken in this separate bundle. So the Webpack API, System.js, asynchronous API look like that, and they will use that to create split bundles. So what these tools work is then a dependency graph for your project. That is, who imports what. So if you take a trivial project, you would have a few classes or scripts, and then all the edges as basically main requires navigation, main requires home, and this requires our hard edges for the graph. But if you say home asynchronously require player view, then suddenly all this subtree becomes something that could be taken in a separate bundle. So we can sort this and split that into a first bundle with what is necessary for startup and another one for another feature. And as I said, that's something that is doable in JavaScript because, well, all the scripts are separate, so you can pick them, put them together, and make different bundles. Why in Haxe we have to do something. So there's been different work around that. So one idea is like monolith.js and the new haxe-modular is to export one JavaScript file per class. So basically it kind of works. So in terms of projects, modular.js seems to be a bit in a dead end with a number of folks working on it and no strong direction. haxe-modular is a new project from Kevin, who talked about Think Web yesterday, and that's a pure nice macro-based approach to that, and that's pretty clever. He's working on solving really difficult problems that arise from creating one JS per file, which are namely the circular references that you can have in Haxe, but that work very badly with CommonJS. But I think that's a very interesting long-term solution, but not the one I want to use. However, still to note, it's very good for making Npm libraries using Haxe for JavaScript consumption. So you can export your Haxe code into individual JavaScript files that can be consumed by a JavaScript language, and that becomes interesting as a use case. And the other one is React Native, where single files work nicely. So by all means, check haxe-modular. It's really smart, and I think it's a good direction. That is not really what I wanted because, well, first of all, these two projects do not bring the concept of asynchronous dependency, first of all, though that could be retrofit at some point. And second, they require the usage of a JavaScript bundler. We cannot deliver anything to the browser without a bundler. So that's okay for React Native because it behaves like Node.js, but not for the browser. And I kind of wanted to have something that can emit the bundles, and these bundles would not even need a JavaScript bundler. And I wanted to preserve the source maps, which was, although I personally don't use them a lot, I think they are useful for for a lot of people, they prefer using mapped scripts, and I wanted that to work, and definitely that was not even in a possibility for modular.js. Maybe a checks JS can do it, and so I look at that in the future to maybe use that as a backend. So so I got something that works. It's a bit brute force, but I'll go a bit about it. So let's go. So I've experimented a few times with that, and even last year I was showing something about that. I did first very naively. I was doing multiple builds. I was doing Flash-like at the time when you try to compile each of your pieces and exclude what you don't need. But I got something that works. So to achieve that, I've done a tool which is haxe split, and what it does is that it parses your haxe output. So it's a Node.js tool. So because I'm using some pretty useful libraries, so the tool parses the output, makes the AST, builds a dependency graph of all your code and even the tool functions from haxe, and builds a and then we have the graph. So use a graph library also to process the graph and see how we can cut it. So this tool is pretty fast. It's pretty fast. So for several megabytes of JavaScript, it takes a couple of seconds to parse, transform, extract, emit. One very big part of the work is for the source maps. Source maps are incredibly complex to process. So this library, the Mozilla library for that, which is the standard, but it takes quite some time, and that's a reason why, if you look one time at Webpack, you will see that it offers something like half a dozen different ways to transform the source maps, depending on what you want to achieve. Do you want precision, speed, or whatever? So that works, but in itself, this tool does not provide any API for us to use in our code. Just a little disclaimer: it is extremely aggressive. So even what you add, keep, or whatever, that will die. So you have to have explicit references to the code. Like if in the JavaScript generated code there's no references, it's out. So usage. So as I said, haxe split in itself is just a tool that gets a JavaScript file, the split points, and break it down. In itself, it's not an API. So I came up with not one but two options to use it. So one is modular, which is a standalone way to use code splitting with haxe, and the second one is Webpack. So not one but two different options, and depending on your need, you will see what you can use. So API wise, so here's our asynchronous require. It's very close to what is done in JavaScript, and essentially you can just import normally your class, create variables normally, use it in functions normally, but before you can use this class and can instantiate it, you have to load it, and you load it by passing the class name, the class reference, and some macro magic will do its job. And when it's loaded, when the prom is complete, your code is in, as if it had always been in your JavaScript file. So the player and all these dependencies are all extracted. It's a standalone drop-in enhancement. So about any tool chain, I tried it with OpenFL, any tool chain can get their code split. It's not, it doesn't have any limitation except the way you architected your project that would prevent you to split your code. So if you have a very heavy central MVC dependency injection where everything is in a central context, so yeah, that will be hard to cut. You will have to create subcontext or whatnot, things like that. But essentially that you can just use that in any project existing, and you can cut your output. The other is Webpack. So you can see there's a very big difference. So instead of bundle load, you do Webpack load, and you do the same, and it will work in Webpack. So if you want to use the king of bundlers, you just it just works. So but then you have to buy in Webpack. So to give you a bit about what is Webpack, it's become a meme. It has its complexity is legendary. It's a false impression, I would say. It's because you're in a world where you have a million JavaScript developers and there's 1% that are competent. So obviously it's very difficult to get through that, but it is nothing even, it's not even remotely as complicated as the toolchain we have at Massive. Yeah, so this one thing is that it is a bundler technically, but in practice it makes obsolete task runners like grunt and gulp. That's the graph. So that's the first was they all basically were almost created at the same time. So grunt takeoff is used, and then gulp takes off, replaces grunt, and then Webpack starts and kills them both. So what happens is that as a tool, Webpack is a bit, if I'm trying to get a sketchy similarity, if Webpack is to task runners what functional programming is to imperative programming. It's like way above in terms of in terms of being something that is superior and more complicated for the average developer. So Webpack is a universal bundler. That's why it's not just a bundler. Browserify will just get your scripts and make your a JavaScript file. That's amazing. It gets all the dependencies and it's all in. You don't have to think about what you need to include and in what order. And Webpack does that for all the assets and everything that means data, images, styles, everything goes through it, and it will emit your script, final CSS, and images and PNGs and everything. It may sound crazy, but it's really brilliant. So in JavaScript, it looks like that. You can get code, like as before, but then you can also require styles, and the styles will be processed and added to the DOM. You can get data. So this data will be bundled. If you require data, it will be bundled and available as script. You don't have to JSON load using XML HTTP request and then use a JSON parse and try catch and whatnot. For the images, that's the fun thing. So require logo and you get the URL. That's so clever. So you require an image, it returns you the final URL of the asset, and it will take care of bringing the image with whatever name is relevant. Or if you use some optimizer, you can even receive a base64 image instead of a file that will be downloaded. So it's pretty crazy how far you can go with that, and that sounds so obvious. And when you look at that, that means your graph, where we understand all that it's important for code, but that means that you have something that knows every single asset, every image, everything you have in your project, and everything you need to deploy. So it all works using loaders. Hey, it's not in sync. Hey ho, are we disconnected, guy? All right. I don't know. That's fishy. All right. So a loader is one of the great ideas of Webpack. Is that if you want to require a JSON file, you pass it through a JSON loader, and the JSON loader will return JavaScript code. So a loader is a source-to-source transformation. It's a simple function that gets the source of the file that's been required, and it returns synchronously or asynchronously new source. And in the case of a file loader, it will just return a URL and schedule the file to be published. And the loaders can be combined. So if you want to have a YAML loader, you use a YAML loader that transforms the YAML into JSON. Then you use a JSON loader that transforms the JSON into JavaScript. That's that's composition. That's simple. That obviously that's not really. I mean, in Haxe you would say, yeah, I'm just going to use a macro and generate my code. But in itself, that's a pretty fantastic solution to a problem, and that works really well for the JavaScript developers. And it's really easy to create these loaders, and it's pretty fun to do. So that's really the secret. And we have a Haxe loader, and when you use Webpack in your Haxe code, then you can require styles, you can require data, you can require images. That works the same as in JavaScript. And one of the big things is the requires are correctly relative to the class you're in. So if the way Webpack suggests to do things is that you put together your code, your CSS, your local assets, image assets, and you can require them from your code relatively. And that just works now using our loader and our helpers. So the Haxe loader works based on loading an HXML file. So you require an HXML file, and it will be built, split, and everything, and just automatically. So you can use that as your general Webpack entry point. So you can be purely JavaScript free and just require your HXML, and that's your output. And it will be split if you use the split API. Okay, last word about Webpack is the plugins. So loaders is one thing, but the other thing is the plugins. So the plugins they operate on the tree of bundles. So every time you do an async, or it will create new bundles. So you have a bit like an AST. You have a tree of the bundles that are going to be published, and the plugins can operate on all the assets that have been required. Like all the images that have been scheduled to be published. It can transform the tree of bundles and say, okay, we're going to apply rules to combine bundles or to extract modules from bundles, to extract additional bundles. It has a very, very powerful capacity to operate on this dependency graph that Webpack has obtained. And you can also add imperative tasks like generating an HTML page or copying some static additional assets. And that is essentially why it kind of ate the task runners meal, because what you need in imperative operations that the task runners would do are kind of covered. So, and it's all fairly documented. So, despite the legendary complexity, in the last 6 months, the documentation has become really, really good, and very, very elaborate. And in terms of the Haxe loader or modular in general, they're pretty extensive readmes and example projects. So that should be fairly easy to get started. And if anything, we can discuss that this afternoon during the Haxe React workshop. We'll talk about splitting, so you can come with your project, and we can discuss how you could and should split it. Okay, so before finishing, I talk about this hot reload. So can we do hot reload? Yes, we can. And it works both with the Webpack approach and the standalone modular approach. So for those interested in React and those wanted to implement things like that, React hot module replacement working even without Webpack. So there's a pretty good infrastructure for people to build smart things with it. So yeah, thank you. That's about it. So if you have any question.
Yeah. I think we, as in the Haxe compiler, should do something differently to help people like you achieve your goals.
Well, this project is totally done really brute force because the compiler doesn't give like a very granular dependency a graph of the dependencies of what is being used. So I really have to do it manually. And the other thing is I think there's the general asynchronous API could be kind of native, could be made native and work on multiple platforms in terms of API. I could totally see that working with, you know, Sepia or we wouldn't bother making that for Flash, but I think there's a number of platforms where that could definitely work. I hope I can use the hx-gen.js later instead of the brute force JavaScript parsing. But one of the big important thing I think was what I'm doing is with Webpack you don't want to generate the files. You know, modular.js and haxe-gen.js generate a crapload of JavaScript files that are just noise, that are just information for the toolings. And with Webpack you can, the Webpack loader does not generate any file. It all sends the output to a temporary file, and then that's all. All the rest happens in memory, and that's the way Webpack works. So one of those is emitting to memory. So we'd like the compiler to be able to return the script and the source maps on purely in memory instead of files, and yeah, and maybe consider an asynchronous API like that. Yeah.
In the past, working with modular Flash projects, one of the interesting ambiguities that gets resolved is sort of the authority of the source of a class.
Mm-hmm.
A class is like a first-order object in the Flash runtime. In JavaScript, there are no classes. I'm wondering at runtime. I'm wondering if the Haxe targets where a class is like a first-order object would, if someone were to attempt something similar to create a modular output, whether because a type is a class in certain circumstances, how that might complicate the process.
So you say that in JavaScript the classes are not first-order elements, but I would disagree. So a function with a prototype is just as valid as a class as the classes that we consider our classes, and that has no direct impact on the question of splitting, because in the splitting we extract Haxe classes and tool functions like the $bind, $extend, and it all can be treated as a module, a bit like a module. Yeah.
Can you detect and handle if the internet connection is down, so the loading will not complete, or the file will not be found, something like that?
Yes, I mean both APIs will have a failure. They are both promises that return you a failure case if it doesn't download. and you can retry it. And the download happens only once, and you can have multiple concurrent download of the same file. You will get the same promise, and they all complete together. And there's a failure case, and you can re-attempt it. Yeah.
You said that it takes a couple of seconds to compile it. Is this actually at the moment for you a problem because actually you wanted to see the change more or less instantly, and if it takes a couple of seconds?
Yes. Alors, if you take a, like say a TypeScript project, for instance, I'm doing quite a bit of that. The iteration, if you save a file between the moment you save it and the moment in the browser, takes many seconds, as soon as the project is not trivial. So the difference, you know, that's this thing where JavaScript starts easy and fast, and then as complexity grows, becomes quite slow, and a medium-sized TypeScript project takes minutes to compile. While the hack speed may be slightly higher for simple projects at the beginning, but that stays fairly slow, as that keeps this profile fairly long when complexity grows. So overall, when that's been this point where you have a slightly steeper learning curve, and that scales very well. Well, in JavaScript you have an easier starting, and it's easier to start dabbling and playing, and it's satisfying, and then you will continue. You will have to march to your goal, sometimes a bit painfully and more painfully as your project grows in complexity. Yes. No. You.
Is there something like a progress event or something that tells you what part of the point you're trying to download is?
So is there a progress event? No, there's no progress event for neither for Webpack nor for Modular, unfortunately. So yeah, yes, this is, I believe for Modular you could implement a progress event because it's using. Although no, not sure. No, I'm not sure we can.
You have to actually load the file per HTTP request yourself, and then mount it into as a script tag.
Yes, it's loaded as a script tag currently.
Yes.
So
as an inline script tag.
yes.
And then you can get the progress if you're in a very modern browser.
Exactly. So you could currently it's been done just we have the completion, but I think you can engineer having the progress of loading. For Webpack, I'm not sure, though. We would have to look in the internals. But for Modular, you could the require script that loads it is fairly simple, so you can re-engineer that to try to get some progress if it's supported by the browser. That's very simple. That's like 10 lines of code, so you can go and improve that. Yeah.
Just from a high level here, the splitting is done according to the hitting the require statement in the source code. Is that right?
Yeah. For Webpack, it generates a require, and
you scan for that and then split according to what's required.
oh no, for the hack splitting.
Yeah.
No, because Haxe doesn't generate any require.
So how do you say which component? I guess.
Oh, that's brute force. Make the AST, have a visitor, get all the identifier, build a graph of the identifiers and the relationship with between the. Can identify what class it corresponds to, and then graph it.
Give everything as one thing. How do you have multiple things? So you can find all the files as one big thing, but if you want to have 3 projects, one for your player view, one with the startup code,
Mm-hmm.
all linked together in one app, how does it know to separate just those things?
Because it can find in the JavaScript AST what code corresponds to a specific class,
So
and
you
then.
split on player view.
It's you know, if your code has, if I know in JavaScript code what part corresponds to the declaration of the class A. In the source code in the tree, in the AST of the class A, I can look at all the identifiers and identify, oh, I find class B, so I can mark in the graph A imports B. And I do that for all the identifiers.
I guess how do you split off A in the first place from everything else?
Well, then you have to do some basic graph algorithm to remove all the.
Okay, you specify A.
Oh, it's just the bundle. It's just the bundle load will say, okay, we want to split that.
The bundle load and then goes from there.
Yeah. So it gets the name of the class, make that an identifier, the same as it would be in the generated JavaScript, and afterwards we can process it. Yeah. Yes?
Can you throw out stuff you don't need anymore?
What do you mean?
Yeah, if
Can you?
load a module,
yes.
for example,
Oh.
a loader, and I'm not never going
You probably can't, because it would be as soon as it's loaded, the scopes have to be joined so that the class is available for the main code. So you could remove the script tag, but all the objects have been referenced somehow. Haxe is going to add them to the HX classes map and this kind of things. So you can't really unload them.
You could try destroying all the prototypes of the bundle.
You could remove the references in HX classes and in the HX exports and this kind of things, but that sounds like would be complicated to track. So yeah, code probably wouldn't be unloaded. Yes.
Does this work with our global registries, like I think it's called HX classes that used for
It does.
resolve class?
It does
So
work.
it's merged on the
Yes. Yeah. So there's some trickery to bridge these kind of objects and to share classes from the main module with the child modules and vice versa.
You can't unload them, so why do you need to split them?
Because you want to load them only when they're needed. Because all code has to be processed, executed, and that is effort before the user can have the interaction with the browser. So it's not that a problem to load them later and not being able to unload this code. It's more about having the smallest initial bundle for your user. Yes?
How can we interact with other JavaScript files that have not been generated by Haxe?
Can you what?
For example, one of the modules, can it be just a JavaScript file from a library made by JavaScript?
With Webpack, yes. Because from Webpack you can require anything. You could require other JavaScript files or JavaScript modules. There is a little bit of trickery with the standalone modular in terms of managing NPM dependencies, but that's a slightly advanced topic. It's explained in the README and we probably has to be taken offline.
And actually, I have another question. Can you use this modular JavaScript file generated by Haxe in a JavaScript project?
You can. Yeah. The thing is if you're going to use a JavaScript bundler like Browserify, and you could try to right now the output doesn't support it doesn't generate a require for modular. It generates some other code that loads the JavaScript that you need. So if you would want that to work with a bundler, we'd need to do a third. And it's probably going to happen because I want that to work with Node.js. Currently, this doesn't work with Node.js. To make that work with Node.js, we need to tweak the output to emit the script with require and file names. So that's something that is next on my list. All right. But for Node, you can just use a big JavaScript or use HX-Jane.js or HX modular.js. But I'll get it to work. Anyone? Good? Happy?